Hi everybody, today we are going to see that session called VERILOG language elements. See, basically whatever the language you have taken, it has the variables, signals and identifier, data types and everything is there. So basically we should know the language elements, how we have to declare, how the task, how the functions and compile a directive. These are the things we are going to see today classes. What are the rules are there to identify any variable and signals? Okay, so that rules are must in any languages. Okay, identifiers are the names of variables and other elements in Verilog code. Any letter or digit maybe we can use it. The underscore and dollar characters are used. Identifiers must not be begin with a digit and it should not be a Verilog keyword. Example, legal integers are a, x1, a underscore b and byte. Okay, but the identifier should not be like starts with number or operators or else like a star b or the numbers. And some other rules. Verilog basically is a case sensitive, hence small k is not the same as capital letter K. And a capital byte is not the same as this byte. Verilog allows a second form of identifier called an escaped identifier. These identifiers are begin with a slash backslash characters, which can then be followed by any portable ASCII characters except white spaces. Example, /234 / signal hyphen name /x plus y. Actually, escaped identifiers should not be used in normal Verilog code. They are intended for use in code produced automatically when other languages are translated into Verilog. Say for example, some languages XHDL, that software tool is there, which is used to convert Verilog to VHDL and VHDL to Verilog. Okay, and the command line, how to mention that one particular line is a command. Okay, there are two forms as like in the same C language. So one is /star, that is the first form. It can be many number of lines, we can make it as a command. And the second one, this one, it's only one line, we want to make it as a command line. Okay, next we should know that how the format has to be. Okay, how we can make it as a format, either single line or multiple line like that. But we know that Verilog HDL is a case sensitive. Verilog is a free format, that is constructs may be written in across multiple lines or on one line also. Okay, the first example is this. Okay, all the content are in the same line. Okay, but the same as this is our format. Okay, this format also applicable. But basically, whatever the design we are using, definitely it has to be reused by some other people also. In such case, they should easily can understand, means we can follow this format, second format. Okay, what is the meaning of the system task and the functions? We have to use the system functions and the task also in anywhere, especially for the verification side. Okay, an identifier begin with the dollar character is interpreted as a system task or as a system function. A system provides a mechanism to encapsulate a behavior that can be invoked from different parts of the design. A task can return 0 or more values. A function is like a task except that it can return only one value. In addition, a function executes in 0 time, that is no delays are allowed, while a task can have delays. However, a system task can't have any delays. The example, $delay. Hello, how are you? The $delay system task displays the specified message to output with a new line character. $time, this system function returns the current simulation time. Basically, these two things are very high level or multiple times we will use in the verification side. Okay, compiler directives. What are the compiler directives? In C language, we have seen that hash define, hash include, hash undef, hash ifdef, hash ifndef. These are the compiler directives are there. The same way in Verilog also we have the compiler directives, but we have to mention by using the back code, or backtick or tick, like that we can say. Okay, certain identifiers starts with a tick backcode character or compiler directive. So we have to tell the system these are the compiler directive. How? By using the tick symbol. Okay. Until another compiler directive says otherwise, a compiles directive when compiler is in effect for the duration of the compilation process. These are the list of compiler directive: tick define, undef, ifdef, ifndef, else, elsif, endif, default net type, tick include, tick reset all, tick timescale, tick unconnected underscore type, tick no unconnected hyphen drive, cell define, cell end cell define, tick line. These are the things we will see one by one. First one is a tick define. How? What is the purpose of that? The tick define directive defines a macro with its definition. It is used for text substitution and is very much like the hash define in the C language programming. Here is an example. Tick define max underscore width 64. Tick define max underscore size 128. Then we can able to use this max width in register. Max width, tick max width hyphen 1 down to 0. The meaning is what? Total length we mentioned is 64. Here it will be -1. So 63 down to 0. Totally it will be 64 bits. Here also like that. Max size 128 mentioning. So 1 to 127 to 0. So totally 128 bits are allotted for the signal called control. Okay, next undef. Once the tick undefined directive is compiled, the define stays in effect through the entire compilation. For example, max underscore width could be across many different files with a tick define directive in another file. The tick undef directive removes the definition of a previously defined text macro. Example, tick define word length is 16. Here we are using in wire definition. Wire tick word underscore length :0. The wire name is ready. Okay, next undef word underscore length. The meaning is what? Thereafter, if you are using word underscore length directive, it will become error. The definition of word length is no longer available after this undef directive. There is one guideline is there for defining the directives. Use all uppercase characters in a macro name. Then we can easily identify, okay, those are directives. Okay. Then some other, if def, if endif, else, elsif, endif, we are going to see that. These compiler directives are used for conditional compilation. There are two forms of directives in tick if def and the if and f forms. The tick if def form checks the existence of the definition of the macro, whereas the if and def form check for the lack of definition of the macro. Okay, the first example, if def range parameter word underscore size, the length we have given is a 16. Across the program we can able to use tick else parameter. Otherwise, if range is not defined anywhere, we can say the word size is 32. Otherwise, if range defined previously, then the word size is 16. During the compilation, if the text macro name range is defined, the first parameter, again I am telling, the first parameter declaration is selected, otherwise the second parameter declaration is selected. Tick else directive is optional with the if def directive. The if endef directive is the opposite of tick if def, which says no, do something if macro is not defined. The else if directive is equivalent to tick else followed by a if def directive. Then some other directives, tick default underscore net type. This directive is used to specify the net type for implicit net declaration, that is for nets that are not declared. Okay, the tick default underscore net type wand, default underscore net type wand. This wand, NAND or something is there. Those are the things we will see in the upcoming upcoming videos. This directive must appear outside of a model. This example specify the default net type to be a WAND net. Therefore, if a net is not declared in any model following this directive, the net is assumed to be a WAND net. A value of none can also be specified as a default net type. This indicates that no implicit nets are allowed. Tick include. The tick include compiler directive can be used to include the contents of any file in line. The file can be specified either with a relative path name or with a small path name or else with a full path name. Tick include within double quotes /hello.v. Upon compilation, this line is replaced with the contents of the file hello.v. The next one is a tick reset all. This compiler directive resets all compiler directive to their default value. Tick reset all. This is that directive name. For example, this directive causes the default net type to be a wire. The next one, very important thing, is tick timescale. Because all our hardware languages are related with the time. Okay, specifically in C language, those are sequential basis. But in Verilog or VHDL, all are hardware basis. Here everything is based on the time only. Okay, in Verilog HDL, all delays are expressed in terms of time units. The association of time units with the actual time is done using the timescaler compiler directive. This directive is used to specify the time unit and time precision. The directive is of the form tick timescale, time unit and time precision. Here the tick timescale, that is the directive. Okay, whereas the time underscore unit and the time underscore precision is made up of value from 1, 10, 100 and the units from S means seconds, ms millisecond, US microsecond, PS picosecond, FS femtoseconds. This is an example. Tick timescale 1 nanosecond, 100 picosecond. How it is going to run? It indicates a time unit of 1 nanosecond and a time precision of 100 picoseconds. The tick timescale directive appears outside of a model declaration and affects all the delays values that follows it. Here is an example. Here we are mentioning tick timescale 1 nanosecond / 100 picoseconds. Second one is the precision. Okay, here the module is R function. Okay, R function y a comma b, output y, input a comma b. Here R gate. Okay, after the hash we are mentioning that time scale and units. Okay, 5.11, 6.34. How it is going to execute in the background? Okay, that is the instantiation of the R gate. No need to confuse that. Okay, here y is the output, a is the input and b also is the input. Okay, here the first one we are mentioning, that is rising delay specified. The output which we are getting, that output delay, that is a rising edge or falling edge. Okay, whereas in the input, another one, falling edge, it's a 6.34. In the 6.34, the falling edge will be specified. Okay. The directive specifies all delays to be in nanosecond and the delays are rounded to 1/10 of a nanosecond, that is 100 picosecond. Therefore, the delay value 5.11 becomes 5.1 nanosecond and the delay value 6.34 nanosecond becomes 6.3 nanosecond. These result, the value of 5.1 as well as the 6.3, we will see in model sim software. Okay. See, for that purpose, we have taken that one R function. Okay, the implementation of R function by using only one R gate only. Basically, R gate having a single output and two inputs. So here, A as well as B both are inputs and Y is the output. At the initial stage, the inputs we are defining by using the force function. See, ST0, that is the first value, that is it is showing that is logic 1. Okay, in the B, that is showing the logic 0. The output will be, it will goes to the falling edge. See, after the after this time duration, we are making that A signal will be 0. So the output will be 0. But when it is coming that output, that is that matter. Okay, here we are mentioning, already we have mentioned that falling edge is 6.3 nanosecond. Here you can see that output after 6.3 nanosecond we are getting that output. Okay, for rising edge information, look at here. At this duration, the output will be that the signal B will be 1. Okay, the output we have to get logic 1 after the 5.1 nanosecond, which is showing here. Okay, right. Time scale, another some important information regarding that time scale. Time scale directive affects all delays in modules that follows this directive in a compilation until another time scale directive or reset all directive is found. Okay, there is a doubt. What happens if there is more than one module in a design, each having its own time scale directive? In such a case, simulation always takes place in a smallest time precision of all the modules, and all delays are appropriately scaled to this smallest time precision. Okay, another some directives. There is one directive called unconnected drive and no unconnected drive. Any unconnected input ports in module instantiation that appear between these two directives are either pulled up or pulled down. How we are going to mention either pull down or pull up? Here you can see that next one, that is the example for pull up. Okay, tick unconnected underscore drive pull 1. Okay, see up to dot 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 and finally end with tick no unconnected hyphen drive. It is hyphen. Okay, so all unconnected input ports between these two directives are pulled up. Okay, now another tick unconnected drive pull 0. Okay, with the end with no unconnected underscore drive /0. All unconnected input ports between these two directives are pulled down. Okay, another very important, tick cell define and tick cell end cell define. These two directives are used to mark a module as a cell module. They typically encompass a module definition as shown in the following example. See here, this is the smallest module which are inside that cell definition. Okay, cell modules are used by some PLI routines. A cell module typically has a specific block that specifies the delays of the block. PLI routines can use this information to perform delay calculation for such cells. Okay, in future videos we will see based upon all those things, either model sim software, how to install the model sim software, or how to start with the project in the model sim, as well as the cell delays. These are the things we will see in the upcoming videos. Thank you. Oh, I forgot the last one. The tick line directive resets the line number and file name in a Verilog HDL compiler to that as specified. Tick line 52 reset.vg. This directive is useful for Verilog writer tools such as preprocessors. When an automatically generated Verilog HDL file is compiled, the directive values are used to issue messages as it relates to the original file. An user would typically not use this directive directly. Okay.